Hello and welcome to this video. In this video we will study problem number 191 to 200 of complex numbers. It's a continuation of our previous videos on complex numbers. So without further ado, let's get started. And as always, I say that when I am stating the problem, you should pause the video and try to solve the problem yourself. If you cannot solve the problem yourself, only then look at the solution. Problem 191 says that if z minus 6 minus 8i is less than equal to 4, then find the least and greatest value of z. So what we do is we have this inequality that mod of z minus 6 minus 8i is less than equal to mod 4. So that implies that minus 4 is less than equal to mod of mod z minus mod of 6 plus 8i. So we split the modulus of these two complex numbers z and 6 minus 8i, and this will be also less than equal to 4. So then what we do is, there is a mistake. This 10 should have been 4. The modulus of 6 plus 8i is 10, so we take out these two from modulus. So we will have minus 4 less than equal to mod z minus 10 less than equal to 4. This is 4. So then we take 10 to the right and to the left, and we will have 6 less than equal to mod z less than equal to 14. Problem 192 says that if z minus 25i less than equal to 15, then find the least positive value of argument of z. So you see, this is the diagram. Since complex number is z minus 25i, so that means the center is at 0, 25, that is over here, and 15 is its radius, so it's a circle. And since we have to find the point which has least argument, what we have done is from the origin we have drawn a tangent. So this tangent will represent the argument theta, which will be least. Okay. Now since this is theta, from geometry you can figure out that this will be theta, because this angle XOP is theta. If this is theta, then POC will become 90 minus theta, because XOY is 90 degrees. So POC will be 90 minus theta. Now since this is a tangent, CP is a perpendicular. So this angle is 90 degree and this is 90 degree minus theta. So this will automatically become theta. Now we have that its position is 25, 0, 25. So CO will be 25. Okay. And the radius is 15, that is CP is 15. So OP will be square root of 25 square minus 15 square, that is 20. So once we have OP, that is this, and CP, which is 15, we find that tan theta is OP by CP, it is 4 by 3. So the least value of argument would be tan inverse 4 by 3. Problem 193 says that show that the equation mod z minus z1 whole square plus mod z minus z2 square is equal to k, where k belongs to real numbers, that will represent a circle if k greater than equal to half mod of z1 minus z2 square. So we are given that mod of z minus z1 square plus mod z minus z2 square is equal to k. So we expand it, we get mod z square plus mod z1 square minus 2z z1 bar plus mod z square plus mod z2 square minus 2z z2 bar is equal to k. Now what we do is we take this z1 square and z2 square and bring them to right side. From the left hand side, the 2 mod z square become 2 mod z square minus, we take these two, take out 2z, and in the bracket we will have z1 bar plus z2 bar. We will, on the right hand side, we will have k minus mod z1 square minus mod z2 square. Then we want to make a sum for left hand side, so we add 1 by 4 mod z1 plus z2 square. So you see here, what we have done is we have divided here by 2. Okay. So once we have divided, this has become mod z square minus 2z z1 plus z2 bar by 2. So you see, to make this a full square, what we have to do is we have to add 1 by 4 mod z1 plus z2 square. We have subtracted the same from right hand side. So this becomes mod z minus z1 plus z2 by 2 square is equal to half k minus 1 by 2 z1 minus z2 mod square. So now you can see that this equation represents a circle with center at z1 plus z2 by 2 and radius 1 by 2 square root of 2k minus mod z1 minus z2 square. But the radius has to be positive, so 2k should be greater than mod z1 minus z2 square, that is k greater than equal to mod z1 minus z2 square by 2. Problem 194 says that if mod z minus 1 is equal to 1, prove that z minus 2 by 2 is equal to I tan argument of z. So we have drawn the diagram. So it is z minus 1 is equal to 1. That means center will be at 1 comma 0 and its radius would be 1. That's why it will touch the O also, because the center is 1 0 and radius is 1. Now we have let z is equal to x plus iy. So this will become x minus 1 whole square plus y square is equal to 1. It will give us x square plus y square is equal to 2x. And we are given that z minus 2 by z has to be found. So we write this as x minus 2 plus iy by x plus iy. And then we rationalize this by multiplying and dividing with x minus iy. So in numerator we have x square minus 2x plus y square plus 2iy divided by x square plus iy, x square plus y square. Now you know that x square plus y square is equal to 2x. So this real quantity will become 0 and we will have I pi by x, because we substitute here 2x. So 2 will get cancelled and y and x will remain. Now there will be two cases. As you can see from the diagram, the upper semicircle lies in the first quadrant and the bottom semicircle lies in the fourth quadrant. So when it lies in the first quadrant, the argument would, the I tan argument of z would be I tan theta, which will be equal to iy by x. But when it lies in fourth quadrant, argument of z would be 2 pi minus theta. So that will become tan theta is equal to minus y by x. So I tan argument of z would be iy by x. Problem 195 says that find the locus of z if argument of z minus 1 by z plus 1 is equal to pi by 4. So we let z is equal to x plus iy. So we have, on rationalization, z minus 1 by z plus 1 is equal to x square minus 1 plus y square divided by x plus 1 whole square plus y square plus I 2y by x plus 1 whole square plus y square. Now we are given that the argument is pi by 4, that is 1. So we will have 2y by x square minus 1 plus y square, because this denominator will get cancelled for the argument. We'll have this value is equal to 1. That means x square plus y square minus 1 minus 2y is equal to 0. That is x square plus y minus 1 whole square is equal to 2, which is actually an equation of circle with center at 0, 1, radius square root of 2. Problem 196 says that if alpha is real and z is a complex number and u and v be the real and imaginary parts of z minus 1 into cos alpha minus I sin alpha plus z minus 1 to the power minus 1 into cos alpha plus I sin alpha, prove that the locus of the points representing the complex number such that v is equal to 0 is a circle of unit radius with center at a point 1 0 and a straight line passing through the center of the circle. So we have z is equal to x plus iy. Now it is given that u plus iv is equal to z minus 1 into cos alpha minus I sin alpha plus 1 by z minus 1 cos alpha plus I sin alpha. So we expand this. We rationalize the 1 by z minus 1. We have x minus 1 I minus Iy by x minus 1 whole square plus y square into cos alpha plus I sin alpha. So now what we do is we equate the imaginary parts. So for v, we will have y cos alpha, that is y cos alpha. For v, y cos alpha will take out. Then minus x minus 1 sin alpha, that is this part. And from here, we will have x minus 1 sin alpha minus y cos alpha by x minus 1 whole square plus y square is equal to 0. That means y cos alpha minus x minus 1 sin alpha into x minus 1 whole square plus y square is equal to 0. Okay. So once we have this, either y cos alpha minus x minus 1 sin alpha is equal to 0, which gives us y is equal to tan alpha into x minus 1, which is a straight line passing through 0, passing through 1 0, or x minus 1 whole square plus y square is equal to 0. That means it is equation of a circle which is having center 1 0 and radius unity, that is 1. Problem 197 says that if mod of an less than 2 for n is equal to 1 to 3 and so on, and 1 plus a1z plus a2z square plus up to an zn is equal to 0, so that z does not lie in the interior of the circle mod z is equal to 1 by 3. So we are given that 1 plus a1z plus a2z square plus up to an zn is equal to 0. We take modulus of both sides. So 1 we bring to the right hand side, and modulus gives us mod a1z plus mod a2z square up to mod an z to the power n. This should be n, not b, greater than equal to 1. Now, left hand side, if we take this and we are given that mod n is less than 2, we substitute 2 for all of these a1, a2 and so on. So we get 2 mod z plus 2 mod z square and so on. We expand this up to infinity. We make n tending to infinity. Now sum of this is 2 mod z by 1 minus mod z, which will be less than equal to 1 in case mod z is less than 1. So mod z will be greater than 1 by 3 from this inequality. The second case, when mod z is not less than 1, that is mod z greater than 1 or equal to 1, then in that case it is already greater than 1 by 3. So in both the cases, when mod z is less than 1 or greater than 1, z will not lie in the interior of the circle with radius 1 by 3. Problem 198 says that show that all the roots of the equation z to the power n cos theta 0 plus z to the power n minus 1 cos theta 1 and so on up to cos theta n is equal to 2, where theta 0, theta 1, theta n all are in the set of real numbers lie outside the circle mod z is equal to 1 by 2. So we are given that this equation is given. So we take modulus. We have 2 is equal to mod of z to the power n cos theta 0 plus z to the power n minus 1 cos theta 1 up to cos theta n. Now we rewrite this and we make this less than, this will be less than mod zn cos theta 0 plus mod zn minus 1 cos theta 1 and up to cos theta n. Now we take out both the terms zn and cos theta, we separate them. We have this equation. Now we know that cos theta, modulus of cos theta is always less than equal to 1. This equation is equal to mod of z to the power n plus mod of z to the power n minus 1 plus up to 1. And clearly this is less than 1 plus mod z plus z mod z square up to infinity. Now from this, what we gather is 2 is less than equal to 1 by 1 minus mod z. That is mod z is greater than half. That is when mod z less than 1. And therefore we gather that z lies outside the circle mod z is equal to half. So from this we deduce that all the roots of this equation, which is z, lies outside the circle mod z is equal to half. Problem 199 says that z1, z2, z3 are non-zero, non-collinear complex numbers such that 2 by z1 is equal to 1 by z2 plus 1 by z3. Show that z1, z2, z3 lie on a circle passing through origin. So we know that if 4 points z1, z2, z3, z4 are concyclic, if z2 minus z4 by z1 minus z4 into z1 minus z3 by z2 minus z3 is real. So we take the fourth point z4 as the origin. Okay. Now we are given that 2 by z1 is equal to 1 by z2 plus 1 by z3, that is z1 is equal to 2 z2 z3 by z1 plus z3. So now we put the value of z1 in this equation and z4 as 0 in this equation, and then we will obtain that the value is of this expression is half. Half is a real quantity, and thus we deduce that all the 4 points are concyclic, where the fourth point is origin. Problem 200 says that A, B, C are the points representing the complex numbers z1, z2, z3 respectively on the complex plane, and the circumcenter of the triangle ABC lies on the origin. If the altitude of the triangle through vertex A meets the circle again at P, prove that P represents the complex number z2, z3 by z1. So we have this circle, we have 3 points A, B, and C, z1, z2, z3. O is the circumcenter, which is origin. We drop the perpendicular from A, we have PZ. Now, since O is circumcenter, therefore OA will be equal to OB equal to OC is equal to OP. So we will have mod Z is equal to mod Z1 is equal to mod Z2 is equal to mod Z3. So we square them, they will be equal, and we have this equation here. From the mod Z square, we expand this. So we have this equation. Now, since AP we know is an altitude, therefore it will be perpendicular to BC. Therefore, argument of Z1 minus Z divided by Z2 minus Z3 will be pi by 2 or minus pi by 2. Therefore, this quantity Z1 minus Z by Z2 minus Z3 will be purely imaginary. And therefore, conjugate of this would be equal to minus of that. Now, once we have this equation, we use these equalities from here in this equation, solve this, and we will have Z is equal to Z2, Z3 by Z1. So with this, we come to the end of this set of problems. I hope you have found this video useful and informative. If so, please subscribe to the channel and like the video, because that does two things. First thing, it motivates me to make more such videos. And second, as you know, YouTube algorithm will show this video more in searches and in suggestions if you like and subscribe. So that will help the video reach many more students like you. Thanks a lot for watching. Have a nice day.